Hi, we are the BSIT student from Technological University of the Philippines, and we are here to discuss the Open Systems Interconnection, or the OSI model. The Open Systems Interconnection model is a conceptual framework that describes networking or telecommunication systems as 7 layers, each with its own function. The layers help network pros visualize what is going on within their networks and can help network managers narrow down problems. Tech vendors selling new products will often refer to the OSI model to help customers understand which layer their products work with or whether it works across the stack. Layer 7, or the application layer. In the OSI model, the closest to the end-user layer is the application layer. It receives data from the consumers directly and shows it to them. Surprisingly, the application layer does not include applications themselves. Layer 7 communications include web browsers, such as Google Chrome, Firefox, and Safari. Layer 6, or the presentation layer. The presentation layer denotes the part of the application layer that is not affected by data representation. In general, it refers to the process of preparing or translating application format to the network format, or network formatting to application format. To put it in another way, the layers presents the data to an application or network. Encryption and decryption of data for secure transmission is an excellent example of this layer. Now, let's move on to the layer 5, or the session layer. A session is generated at the session layer when two computers or other network devices need to communicate with one another. Setup, coordination, and termination between the programs at each end of the sessions are all functions performed at this layer. Next is the layer 4, or the transport layer. The transport layer is in charge of data transfer coordination between end systems and hosts. How much data to transfer, at what speed, where it should travel, and so on. The Transmission Control Protocol, or TCP, which is constructed on top of the Internet Protocol IP, is the most well-known example of the transport layer. Layer 4 deals with TCP and UDP port numbers. Let's move on to the Layer 3, or the network layer. Most router functionality that most networking professionals care about and love can be found in the network layer. This layer is in charge of packet forwarding, including routing across different routers in the most basic sense. Next is Layer 2, or the data link layer. The data link layer performs error correction from the physical layer and offers node-to-node data transfer between two directly connected nodes. The media access control layer and the logical link control layer are both present here. The majority of switches in the networking world operate here at Layer 2. Last but not the least, the Layer 1, or the physical layer. At the bottom of our OSI model, we have the physical layer, which represents the electrical and physical representation of the system. This can include everything from the cable type, radio frequency link as in a Wi-Fi network, as well as the layout of pins, voltages, and other physical requirements. For example, when networking problems occur, many networking pros go right to the physical layer to check that all of the cables are properly connected and that the power plug hasn't been pulled from the router, switch, or computer.
Created using Powtoon.